Now let's talk about file input and output. We have used system.in and system.out and the standard class for input and output. But up until now, we have only done reading from the keyboard and writing to the screen, right? System.in and system.out are kinds of streams. And this is a cool idea that came, or at least was popularized by the Unix people. The idea is you have several things that can be represented or thought of as just a bunch of bytes, right? If you're thinking about the keyboard, every key is just one more byte, right? But you can use the same abstraction for files if you read them sequentially, and at that time there were also tapes, right? If you're reading files from a tape, you're just reading bytes one after the other, and then even the network can be seen as bytes one after the other. So that's the idea of a stream. We have input streams from which you read bytes one after the other, and we have output streams to which you write bytes one after the other. And you can use that both for network devices like keyboards and mice and screens, and or terminals, and files on a file system. The input stream class has not very useful stuff, but it's kind of the most basic ones. You can ask it how many bytes are available, or how many bytes it thinks it's available. If it's something like the network, then it doesn't know. You can close it. You can sometimes mark and reset to go back and forth, but that's not commonly done. In fact, mark supported tells you whether it is supported or not. And the most important thing, you have read. You can read 1 byte. It's actually, you read 1 byte, but it returns an int because it will return -1 if the end of the stream is reached. The other thing is it throws IO exception if an IO error occurs. So let's look at what a function that takes those things would look like. Normally we were using print streams, which is a subclass of output stream, and we were using scanners. So let's do directly an input stream. I have to declare that it throws IO exception, because read and write on an input stream may throw IO exception. And I also sorry, never mind. What I'm gonna do, I'm gonna create an int variable. I'm gonna read always, and I'm gonna break in the middle. I read 1 byte. If it is equal to -1, then I break. So if I reach the end of the stream, I break, and then I write to this output stream. So in my main, I can have cat, which was the name of my function, system.in and system.out, right? If I run this, I can write stuff, and it prints stuff, and Control D is usually the termination for a file, and so that's just kind of, this is the file is done, and so it will stop. I can also, when I run it, and I'm gonna do weird things. Let's see, where am I? And where is this thing? Sorry. I should have figured this before starting to write. So I am interfaces. It's probably in workspace. Documents, workspace. Yay! And I have interfaces. That's where Eclipse writes my stuff. So I'm gonna go search. Actually, not to search. I'm gonna go to bin and then Karamo, so I can run it directly. So I can do Java. I cannot be in Karamo. So I can do Java Karamo dot the name of this guy, which is IO example 2. It's actually running. I can do this stuff. and then this finishes Control D, right? Now I can use input and output redirection and that way cheat and use files. So I see that I have, or let me just type something. So let me cat is an actual Unix command. That's where I got the name of my function, onto home/stuff.txt, and I'm gonna type this is cool stuff and more stuff. So now I have this file, and I can use this guy and redirect input with the less than from there, and it actually read from the file rather than from my thing. If I were using greater than, then it would write it to that stuff. So I could do greater than thingy.txt, and whatever I write here will eventually get put onto thingy.txt. So that way I can deal with files if I want to, but I can also directly in Java deal with files. Java has the idea of a file input stream, which is an input stream that reads from a file. So I can do file input stream f equals new file input stream, and I'm gonna give it a name. What's my /user/Corey, because I'm on a Mac. So /user/Corey/ have stuff1.txt, stuff.txt. I need to tell Eclipse to actually import that thing, and that actually gets added here. It's just Eclipse is nice and does it for me, so I don't have to remember what's the package name. And instead, let me call it fin. Instead of system.in, I'll pass fin. So now it's gonna print that stuff on the console because I'm using fin and I'm using system.out, right? In fact, I could, we have never used these args, but they are actually passed on the command line. So I could do for string arg in args something like this: new file input stream of arg, and then do this. Maybe let me print the argument just so let me do system.out.println /t is for tabs, and I'm just printing something so that we can see it on the screen. By the way, I can tell Eclipse, there is some way of telling Eclipse how to do the arguments, but I normally don't memorize that stuff on my IDEs because it's a lot simpler to do it here, right? I can do this, right? And now whatever I pass is gonna try to read those things. So I pass this one. I can also pass home/stuff.txt. And so it prints thingy.txt, it prints home/stuff.txt. That is the main thing about files. We also have, let me go back to here. We have very similar things with a file output stream, and system.out is a print stream, which is a kind of file output stream. We have writers. We have readers and writers, and we have scanner. So when you have a chance, go look at those classes and what kind of methods they have. But this is the basic idea. You read and you write, and it's fairly similar to what we have been doing with system.in.